Hello everyone, for first updates now, I'm Tyler Olds and you're watching Behind the Bot. It's a fun show where we dive deeper into FTC robots, what makes them work, and showcase them. And today I'm here with team number 14615 Turbocharge from Oswego, Illinois. 14615 has been a powerhouse team, Illinois securing finalists at Illinois State Championships in Skystone and winners in Robotics. And in remote events this year, they've had a very respectable OPR of 268.8. And today I'm here with Ryan, who's going to be detailing more of this robot, including custom chassis. We're going to be going through the full aspect of their ring mechanisms, wobble goal, of course, all this and more coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com and let's get your team scheduled to be on First Updates Now. So Ryan, we're going to be starting off on this awesome machine here, starting with your custom chassis. I know you got a cool separate design of it to show it off. So start us out with that, and then we're going to be going into some of your ring manipulators as well.
So for the past few years, I've been using composite chassis, so I have a lot of experience with them. The G10 composite, which is glass-filled epoxy, is incredibly strong. It is around the same weight as aluminum, and it has anti-static properties along with a nice shiny coat to it. I start off by taking the CAD design that I developed of the robot throughout the season. I then will put it into a CNC machine, which I was given to me by my sponsor. And after I cut it, I will bring it back to the shop. I will fit it all together. I have grooves that are cut into the chassis, so all the pieces just fit together nice and neat. Everything is the correct dimension. I apply the epoxy, and after 24 hours, I can begin to attach different components. So it's really nice material to work with, and it is incredibly strong. I've never broken a composite chassis.
Do you know what the weight is on that chassis?
I believe it is around 10 pounds.
So
maybe
that's
a little less.
Yeah, I mean, for what you're getting out of it, that's really cool. When you look at it from year to year, when you're using a composite chassis like this, how does the modularity of that work? Because it essentially becomes one piece, right? So when you need to repair something, you said you never had to break it. Do you have contingency plans in place, so should that happen?
Yes, we do. We can actually go and repair it on the spot. We have occasionally had times when the epoxy was not prepared correctly and it has chipped off. We can, on the spot, go and put quick access epoxy, which will harden within around 10 minutes. We put onto the spot and we leave it, and it's good.
That's really cool. I love to hear about that. And once you start to take us into the scoring mechanisms itself, so at first we're going to be going into your intake and kind of following that ring journey, and of course we'll be talking about your wobble goal mechanism afterwards. But let's start off with your intake on your robot.
So our intake, I've seen a lot of teams who have used multiple different mechanisms, and the majority of them involve a different spool with multiple steps as they go up the ramp to be able to give enough power to get it all the way to the top. We have a 3.7 motor attached to a 2:1 ratio gearbox, which is connected to our intake, and it spins with enough velocity to be able to push the ring from the intake point up into our storage area, which I can demonstrate right here. So it is incredibly fast. It spins at around 3,000 RPM, and it can make it up into the top with almost no problem.
Where did that ring go? Like, is that still in the robot or just fly straight out?
Yes, it is. We have a shield up at the top that curves the ring and pushes into the back, so it falls nice and flush down at the bottom on our ramp board.
Well, let's move into that a little bit more. I'd love to hear more about, literally when you showed it, I thought you pretty much shot the ring right there for how fast it went. So talk to me more about how you're getting that into your magazine, and then we'll kind of transition to your shooter as well too, because I can't wait to see more of that.
So at the base, we have a 3D printed ramp, which we have designed to have the least amount of space taken up on the field. It is incredibly thin, so the ring can go and push right up onto it. Once it reaches there, we have a slot built into it that we can fit our PTFE ramp, which is made with Teflon, so it is extremely smooth and has little friction on the ring. It will go right up funnel using the side panel, and it will hit the top panel, curve around, hit the foam to decompress, so it loses a little bit of velocity and doesn't shoot back into the intake mechanism, and it falls flush down at the bottom. And after we intake multiples, they will stack neatly on top of each other.
If you don't mind, can we actually see like 3 rings intake with keeping the camera kind of right on there? I'd love to see it, just how those fall in on your robot.
Yeah, no problem.
I mean, just to be straight, like with the the frame rate that we have, watching this on video, it literally just looks like they magically teleported into your hopper there. So that's pretty awesome. What was from a design process on that? How many different iterations did you go through to get to this final product on this? Like, was this initially the immediate ideal? You're like, hey, this is exactly what I want to do, or did you go through a few different iterations to get there?
So we do actually go through a lot of different iterations. For the intake ramp curve, we have multiples, but with the intake itself, the whole mechanism was actually fairly quick process. Our original one had a direct drive with the motor feeding right into it, and it had a bit of a complex rail system to be able to hold the wheels together. But after that, it was mainly just refining the small things. We attached the gearbox, moved the motor to behind the ramp, and from there it was just changing small things like spacers. We changed it to a single rail instead of multi. It had the gearbox. So I would say primarily 2 iterations, but also some minor adjustments here and there just to, spruce it up.
I mean, that's pretty incredible that they only have to go through really a couple full different iterations to get to where you are, because it's such a impressive aspect that you have there. So tell us more about what's in your hand right now.
This is actually our custom gearbox. It consists of 2 3D printed panels. One of them has a space for bearings to fit into, so the shaft will spin freely within it. We have the spot for the motor and the attachment points, so it will screw right in. And we also have some carbon fiber arrow shafts that we use as spacers to be able to keep it apart so the gears do not rub against the sides and lose their power due to friction.
And where's that gearbox located?
It is located right on the side, connected to the main chassis. It screws right in. It is easy to access. We were able to replace the motor in its entirety within only 20 minutes.
That's really cool. I love teams that just put that to the forefront, where they're like, hey, stuff's going to go wrong. It's probably going to happen at some point. Let's make it so it's easy to fix as well, too. So let's continue on and talk more about your shooter. I'd love to hear more about some of the aspects, what's worked, what hasn't, maybe how much compression are you using on your rings, that sort of thing. So let's talk more about your shooter, Ryan.
So after the rings make it to the top, we have a servo that is located on the side with a little 3D printed piece that will push the rings into our shooter, which is the spinning wheel, which spins similar to the intake at around 3,000 RPM. The ring uses a 1/4 inch of compression on the ring to be able to shoot it out the front and into the top goal of the tower.
One of the things I want to ask is, how did you, we were seeing a lot of different types of wheels used for the flywheel, essentially, or actually the shooter wheel, I should say, itself. How did you determine to use what looks like a compliant wheel to me, right? So what made you choose that one versus some of the other wheels that are out there on the market?
So during our testing, we wanted one that could easily mold to the ring, since we found that some rings have different sizes, even different weights. So we just wanted one that can conform and squish in with some compression, so it's not all going into the ring. It can also go into the wheel. So this one was the obvious choice. It was stiff, but also squishy to allow what we wanted. And after we start it up and get it fully spooled, you can actually see the wheel itself get stretched out and increase in size, which we find incredibly fascinating.
Yeah, one of the things asking on the wheel in particular, I see that white line on it. So I'm assuming you're using some sort of encoder on that to track everything. Can you talk a little bit more how you're keeping track of your speed or what RPM you're shooting at, and anything else in regards to like when you know when to shoot again, that sort of thing?
So actually, we do not use an encoder with this motor. It is just a simple button that I press and it will spool up. When I feel it's good enough, I press the button to push the ring into it and shoot it out. The white line itself was so we could use a speedometer to test it, and the red cap on the top was to ensure that the shaft does not move. We did some designs and testing where we had the shaft spin freely, and we found that it caused the wheel to wobble side to side and become inaccurate. So we put in a 3D printed spacer at the bottom in place of the bearings that prevents it from moving. We had a problem where it loosened up due to friction. So the cap was just there to make sure that it wasn't spinning.
No, that makes a lot of sense with that as well too. So let's keep moving on, and we're going to talk about your wobble goal mechanism, and then a couple other things to wrap up with as well too. But tell us a little bit more about what you have for wobble goal mechanism and some of the design processes you've gone through for it.
So the wobble lift arm is a very nice mechanism. Our main component on it is our screwdriver, which we have used in previous years for a similar device that we used during the relic recovery season to be able to pick up the relic. It is a simple screwdriver that allows us to raise it up and down at fairly high speeds, and it is incredibly strong, made of ABS plastic. We then have our rack and pinion system, which we use to be able to extend the arm and bring it back in. And we also have two servos at the end attached to a 3D printed cap that allows us to open up and grab the wobble. We originally used one servo on it, but we determined that it did not have a wide enough opening radius to be able to get the wobble efficiently. So we increased it to double after some designing, and now we have a much larger radius and room for error when grabbing the wobble, which makes us a lot faster.
I'm glad you brought that up because that's something I've been asking a lot of teams is how do you determine how much essentially space for error you have when grabbing a wobble goal mechanism. So, I know you said you improved upon it, but what made you determine that the amount of spacing you have is enough space for you when you pick it up? Is it just a feel from being a driver, or is there something else that goes into it?
I would say a lot of it is feel for being a driver. Since I do not have a auxiliary driver to assist me when driving, I have to do all of the controls myself. Every button is carefully mapped out to be able to fit it. All four controls for the arm are located here. So it's mainly just feel. I don't really look at the robot as much as I just feel that it seems to be in the right place. It seems to be working well. But main reason why we adjusted to two servos is because in our auto, when we went back to pick up the second wobble in our one ring autonomous, it was missing sometimes. It would get off by a degree and wind up an inch off when it came to grab it. And just having one servo in an inch of room wasn't enough. So when we increased it, we have a few inches now. We have a much wider radius. We can easily grab onto it, and it makes it a whole lot accurate.
Ryan,
More room for error.
last thing I want to wrap up with is asking you is that your team has had a lot of success over the past few years. What would be a word of advice you maybe give to other teams on who are looking to up their game and become a higher end team and have that success that your team has been having? Is there something that you've noticed in particular the last few years that has really made things come together for you?
Yes, there is. One of the things that my mentors have said that has been repeated constantly is keep it simple. We only have three main moving parts for shooting the ring. We have the intake, we have the servo, and we have the shooter. The simpler it is, the less there is to go wrong, the easier it is to fix, to build. You don't have to think complex. You don't have to think major scale. Just think what's compact, what's easy, and what you can manage.
Well, Ryan, I think that's very well said. Once again, coming in turbocharged 14615. You guys have been making great robots every single year, I know, including for those who watch CRI. I know you guys won that in 2019 as well, too. So great success year after year, and can't wait to see how your team continues to improve upon, and can't wait to see more this year and in future years. Thanks for taking time to share your robot with us.
Thank you for joining me today.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.